In this challenge problem, we'll look at the dot product in relation to one of the best video games ever created, Mario Kart. So for those of you who are unfamiliar with the game, Mario Kart is a series of games, probably the best of all time, where a driver races a course that can oftentimes be laden with boost pads, which propels the player forward as they're driving along the course. Now, if we assume that a player approaches a boost pad with the velocity and direction given by a vector s, and the boost pad provides a propelling force given by the vector b, we want to answer the following questions. What's the dot product of the two vectors? And more importantly, what's the meaning behind the dot product? We want to know at what angle does the player approach the boost pad, and what does this tell us about the skill level of that player? And what would it mean for a negative dot product in this scenario? So what is the dot product of the two vectors? Well, here we have a diagram showing where our speed, the velocity of our vector s, and our vector b, the boost pad. Well, the dot product of s and b we can calculate out using our rectangular coordinates. So s dot b will be 5 times 3 plus 4 times 1, which is 15 plus 4, or 19. So I've now calculated the dot product as 19. But more importantly, what does that 19 mean? Well, s dot b is 19, so could that be the resultant location? They've gone 19 meters. Well, that can't be, because that would be vector addition. If I add these two vectors, that would be where I've gone. So it's not the resultant location, but the dot product is known as multiplication of vectors. So what does it mean to multiply? Well, multiplication can be interpreted in terms of stretching things. So for instance, if I have something of length 2 and I stretch it 3 times the amount, I end up with 6 as my quantity. So it's a stretch factor of what I was multiplying before. So maybe this is some sort of stretch. But I could also think of it in terms of area. Multiplication is also thought of in terms of area. So if I have something of length 2 and I multiply by length 3, well, that's the area defined between those two lengths. So maybe it's something to do with the area between these two vectors, but that sounds something more like the cross product. Well, I know the units are meters squared because I took the x components and multiplied them together, which were meters, and the y components, which were meters, so those would be meters squared. So that lends itself to think, well, maybe it's an area interpretation, because meters squared would be area. Yeah, I'm not really sure. I'm not quite sure what the dot product would mean. Can you think of the interpretation of the dot product in this instance of Mario Kart? What does 19 mean? Let's determine the angle of the vectors between s and b. Well, I know, given my formula, that s dot b will be the length of s times the length of b times the cosine of the angle between them. Well, I know s dot b from the dot product using the rectangular coordinates was 19. I know that the length of s will be 5 minus 0 squared plus 4 minus 0 squared, so 5 times 5 plus 4 times 4. So that'll be of length square root of 41. And the length of b, similarly, will be the square root of 10. So now I have my two lengths, s and b, and I can go back to my equation. So I know 19 should equal 41, square root of 41, times the square root of 10 times the cosine of the angle between them. Now I just need to solve for that angle. So I'll divide each side. So I'll divide each side by the square root of 41 times the square root of 10 to isolate cosine of theta. I'll take the inverse of cosine to get my theta being 20.2 degrees. And indeed, that does look like the angle is 20 degrees. So what does that tell me about the skill of this player? Well, they aligned themselves 20 degrees towards the boost pad. So they weren't parallel with the boost pad, which would give them the maximum increase in their velocity, but they were close. And now we need to determine, well, what does a negative value mean in terms of the dot product? Well, I have the equation for my dot product as s dot b will be the product of the x coordinates plus the product of the y coordinates. So it's the sum of the product of the two numbers, so I need to look at those in terms of what would produce a negative value. Well, that would mean that one of those products needs to be negative and more negative than the other component if it's positive. So here we have an app to explore the dot product. I've defined two vectors u and v, and here I have their dot product. So notice that if they both have positive x and positive y components, well, that's going to result in a positive dot product. Now if I make this vector negative, so now it has a negative y component and a positive x, well, that negative y is counterbalancing and making this negative. But if I were to make them both negative, then you'll see that you get a positive dot product. But it has to be, so if I make this really negative x, but a small y, it's positive, and now it's negative. So even though that this has a small x and y component, this has a very negative x component and balances it out. It's not a very satisfying answer. Those aren't really conditions on the dot product such that it's negative. It doesn't really lend itself to interpretation. Can you think of a better way to understand the dot product, what it means when we have a negative dot product in terms of this example? Thank you again to our sponsors for helping create these videos.